Welcome back to Stewart Science. Today we're going to be talking about slope and y-intercept. Specifically, how we can use our computer to do all of our dirty work for us to find our slope and our y-intercept. But before I do that, I want to just give us a real quick overview about what the point and the use of a slope and a y-intercept are. So you probably learned or are learning in math about this equation, y equals mx plus b. Y is going to be a y number, and x is going to be an x number. So what this equation should let us do is to take an x number, stick it in for the x, and then make a prediction about where it's going to land on the y-axis. Or do that backwards. Give you a y number, you do a little bit of algebra, and you get an x prediction, and so that'll allow us to link two variables, the x and the y. And the specific ratio between those x-axis numbers and y-axis numbers is called the slope. So in science, the slope is the ratio of our independent variable to our dependent variable, or what I call the manipulated variable on the x and the responding variable on the y. So that number is just the ratio. For every one you run, how many do you rise? For every one you go over, how many do you go up? That's what the slope is. So it should be a for every statement. For every one blank, there are this many blanks. For every one x thing, there are this many y things. Let me give you a quick example. If I was going to measure a baby's weight over time, I would let time be on the x-axis and weight be on the y, and the slope of that would be how much weight the baby gains every time. If I was going every month, it'd be this many pounds per month. If I had weeks in the bottom, it'd be this many pounds per week. That's the slope. So the slope is the proportion or the number connection between the x and the y. That's the m in your y equals mx plus b. The b in your y equals mx plus b is the y-intercept, and all that is the starting point. It's not it's not a relational connection. It's just what number did you start at? And so most things that we graph don't start at 0. Here's an example. That baby's weight over time. Let's say she's gaining half a pound every month. All babies have a weight when they're born. And so that baby probably came out 6 pounds, 7 pounds, 8 pounds, maybe something along those lines. So the y-intercept would be 6 or 7 or 8. That doesn't tell us anything about how fast the baby's growing or what her weight is changing by. None of that information is given to us in that b number. All the b number tells us is what weight the baby started at. So if we had y equals 0.5 x plus 7, that baby is gaining 5 pounds every month, 0.5 pounds every month, and started at 7 pounds. That's what that equation is telling us. Now, I talked about how to find all those numbers by hand, but I'm going to show you a trick right now that will save us a ton of time as long as we know how to interpret those m and b numbers. Here we go. So you're going to lose my face while I talk about this because I can't record my screen and my face at the same time. But grab a laptop, grab your MacBook, grab your Chromebook, grab your iPad, grab your cell phone. No matter what it is, go download or go find the app called Graphical Analysis. It's by a computer program called Vernier. So click on manual entry, whatever device you're on. I'm going to be using a Chromebook. I know many of you have a different device, but use whatever device you have, find Graphical Analysis. It might prompt you with this screen, or it might just go to a screen that looks like this right here. Now, we have to be smarter than the computer, so depending on your device, it may or may not pop up to look like this. But when it does, if it doesn't look like this, you need to click on this little View Options button. You can get 2 graphs, you can get 3 graphs, you can get a table. What I want us to select here, what I have selected, is Graph and Table. We're going to be typing numbers into the table and then using the graph that it gives us. And this is the one we want to use probably almost every single time we launch this program. Graph and table. And this is going to make our life so much easier. So I'm going to use the same data that I used in a previous video. I'm just going to type it in. It's going to take me less than a minute. I'm going to fast forward the video here to this part. Okay, that took me exactly 38 seconds. As you can see, as I typed the numbers in, those coordinates started to appear on the screen. So my first coordinate is 0, 20. That's here. Now, I do need to be smarter than this machine, like I mentioned. I need to keep my independent variables in this column, the x-axis across the bottom, and my dependent variables in the y column, which is the vertical axis here. And this is a good graph. Now, again, we mentioned this in my previous video. What I want you to do is to make points on your graph, and then don't connect your points. So no bars, no bar graphs unless you have categorical data. Make points, and then instead of connecting this point to this point to this point, each of these individual points has a little bit of error in it. And so what we're trying to get to is a line graph. So there's a little bit here that says apply curve fit, and this isn't a curve per se. This is a pretty straight line, but we'll have the option once we hit that button, the curve fit, to pick linear. If this is a quadratic function, if we see it start to go up at an increasing slope, or power or inverse, there's lots of different kinds of functions that we can use. We're only going to ever use these two, but this is going to be our main one, linear. So most of the experiments that you'll see in my class are straight lines. Not all of them, but some of them. If I hit that apply button, what the computer is going to do, it's going to break down the slope, the y-intercept, and tell me how well those two numbers are connected. And so you can get to y equals mx plus b, which is your equation for a line. The m, which is the slope, it says 3.04. And if you watched the previous video, we found a slope of 3 just by ballparking where these lines go through. And this b is our y-intercept. What this means, the experiment that I did, these x numbers are time, and these y numbers are temperature. And so we're watching an item's temperature increase as time goes on. We're measuring every 5 minutes, and then we're seeing what temperature is at those times. So if I really wanted to be specific, I could actually tell the computer what I was putting on the x and y axis and what the units are. Because if you'll notice, this m, our slope, doesn't have a unit, and our b doesn't have the unit, and every number that we use in science class should have a unit. So I can go up to this little ... next to the x and think about what I put on the x-axis. And if you'll remember from a previous video, the x-axis that I used here is time, and these are minutes. And for my y-axis, this is temperature. Since we're scientists, we're going to use Celsius. So we added a time in minutes and a temperature in Celsius. And when we hit the apply curve fit, it told us our slope, our m, was 3.04, and our b is 19.15. So basically 3 and 19. Now our numbers gave us 20, but again, these individual points have a little bit of error built into them, which is why we're looking for this relationship. What these numbers tell us, and the very point of me making this video, is that a slope of 3 means that every 1 our graph goes over, it goes up 3. Every minute that went by, the temperature increased by 3 degrees. And what this B means, the B is the y-intercept. It's where the line crosses the y-axis. You can see my zeros down here. So our y-intercept is just under 20, which that is matches our data. And again, this individual point has a little bit of error. Our computer is telling us 19 would have been a better guess, and 20 was what our actual measurement was. Which that's not bad. We're in the right ballpark. We're accurate. This unit would be degrees Celsius. So what this number, our B, means is our starting point. Our M is our slope. That's our relationship. Every 1 time gives us 3 temperatures. Every 1 minute, our temperature goes up 3 degrees Celsius. So the unit would be degrees Celsius per minute. Our B here, which is the y-intercept, just means our starting point. When our time was 0, our temperature was 19. It wasn't 0. So when time was 0, our starting point of the temperature of this water was 19. And what this will all let us do is make predictions. Let's say I wanted to know at 100 minutes, how hot would this thing be? So just looking at rough estimates here, in 100 minutes I would gain 300, because everyone is 3 degrees, and I start at 19. So my good guess here would be 319. And we'll see how close this point is to the line. It's not too far off. You can see it's a little under the line because I used 300 as my guess instead of 3.04. That's okay though. This is an accurate guess. Even way outside my numbers, my prediction is nearly correct, which is why this whole skill is important. To wrap up today's video, slope is the relationship or the proportion between the x-axis and the y-axis. That's the m in our y equals mx plus b. The b is just the starting point on the y-axis when x is 0, and that's the y-intercept. As always, I'm Mr. Stewart. Keep learning, no matter what.